So, good afternoon, everybody. It's a pleasure to be there, to host you, and to start and to open the Sustainability Colliders around the topic of construction and urban futures. Perhaps I will say that today we never produced so many knowledge and innovation, but on the opposite also we are facing some more and more complex situation between geopolitical situation, between also public health and clearly climate change. And we are talking about climate change, we are talking also about many things linked to the constructions and urban areas. And this is the goal of today, through the Collider, to have several perspectives, several visions from entrepreneurs, from corporates, from researchers, to exchange, to showcase and to debate. This is the goal. So let's start with Katrin Beyer, the Dean of the ENAC faculty at EPFL. Just checking that the slides are not running. In any case, don't worry, Katrin, please. She will come to set the scene about the topic of today, and after we can start directly. The next slide also, please, and I will come back later.
Thanks a lot, Frederick. A very warm welcome to this Collider on sustainable construction and urban development, which is organized here as part of the Sustainability Days at EPFL, which are currently taking place. I think all of you know the impact that the built environment has on climate change, on sustainable development, in terms of mass flow, energy consumption, and of course CO2 footprint in general. The impact is immense, so it's really a very large percentage. And for that reason, of course, it's on one hand an impact, it's also a large responsibility that comes with it. And of course, it's also a large opportunity in order to change the future. We also know, of course, that the built environment is something that changes rather slowly, because we don't build just a car for the next 2 years. We build really something that will stay for a long time. Buildings have an average, typically designed for a lifetime of 50 years. To change the urban fabric might take even longer than that. So we really need to plan ahead. We really need to start now. And for such a change, which really needs to be a systemic change, we will need all the actors. And this is really exactly the spirit of this Collider, of bringing together various actors that all work with the same goal of making such a systemic change. So I'm very pleased to welcome you to this event today. I would like to thank the VPS and the Center of Worldwide Sustainable Construction for initiating this Collider. Of course, I would like to thank you for coming, but most of course, also our panelists and our speakers today for initiating the discussion and for really being hopefully at the beginning of a very good change for the future. So I wish you a very good event and look forward to the discussions that we are having today.
Thank you, Katrin. So now the idea, if we can go to the next slide, please. The idea is to have some presentation from researchers, as I said before, so entrepreneurs and corporates, to give their vision, the perspective, but the best thing is also to interact, to exchange, to challenge, and to push the limit together. So, the most important parole I will serve today, and thank you, Rue. She's coming from the Center for Worldwide Sustainable Construction Center as a project manager. You will hear a bit also about this center with Karen Scrivener. Rue will come on stage and she will introduce all the speakers. After that, we will have the moderation for the roundtable, and you keep in mind that you can ask questions also, so you will have a time for that. Don't keep in mind that, and remember your question, and after it will be the open floors also for you. Rue, please, the stage is yours.
Thank you so much, Fred, for the introduction, and thank you everyone for joining us. So before we jump right into all the presentations, I thought it would be necessary to just frame what the discussion will be all about. So, the world is entering a period of unprecedented urban growth, as well as population growth. And at the moment, 50% of the world lives in is urban population, but by 2050, it will be 70% of the world that's living in cities. That's 2.5 additional inhabitants that are currently not living, 2.5 billion, that are currently not living in cities. And that means the cities are supposed to expand to accommodate these new inhabitants. And as you can see, up to 2026, the world will be adding an equivalent of New York City in floor area every month for the next 40 years. And 3/4 of the infrastructure that we need to build technically doesn't exist at the moment. And of course, this sounds like a daunting challenge. And if we look at the projected growth rate, majority of the growth rate will be in emerging markets and developing economies. And that's why when we have these conversations, it's a two-layered conversation that needs to be had. When we're looking at developed countries, a lot of them are going to experience minimal to no growth in their urban centers. So that's where we can argue, build less, build better. But when we're looking at Sub-Saharan Africa and Southeast Asia, where there's still a lot of growth that needs to happen, these cities still need to build the infrastructure that they need to accommodate these additional inhabitants. So, the main challenge that we are all aware of. The built environment contributes 42% of global emissions annually. Just take that in, 42%, whether it's direct or indirectly. And at the moment, there's been a strong contribution from operational emissions, which is the energy that goes into buildings. But if we continue with the business as usual, by 2050, majority of those emissions will be from embodied emissions, which would mean majority of the emissions from buildings their lifetime emissions would have already been accounted for before the building has even been used. Which is why it's important for us to take into consideration then the embodied carbon just as much as the operational carbon as we move forward. And just as we're about to move to our first presenter, I would like to have a Slido question up. And everyone, if you just take out your cell phones, there'll be a little question up for you on the screen, just to get us interested and engaged. Okay, this is the first question. I'll give you 30 seconds to just instinctively answer what you believe. Okay, can we have the answer up? Okay, interesting. We can move on. That's an interesting vote. Just hold on to the fact that everybody thought 20%. The second question. Okay. Thank you so much for your contributions. Reuse and circularity and design efficiency. Noted. Right, so our first speaker, Professor Katrin Scrivener from the Lab of Construction Materials, will briefly be able to provide answers for those very interesting solutions, very interesting answers that you had. Professor Scrivener, if you could come up.
Thank you very much, Rue, for the introduction. And yes, I'll try and give you answers to some of those questions. And, you know, we're talking about embodied energy, so we're talking about materials. So we kind of need to look at, you know, if we look in the next 25 years, which is what we should focus on to confront climate change, the question is, what materials will we be using? And to understand that, we need to start with what materials we're using today. So we recently published this analysis in Nature Communications, and it probably surprises most of you to realize that 3/4 of materials we're using today are based on cement. That's to say concrete, mortars, etc. But what's perhaps more surprising for many of you is to look at this right-hand column here, where we focus on the associated CO2 emissions. And you'll see, even though cement-based materials are accounting for 3/4 of materials, their contribution to CO2 emissions is proportionately much less. It's very significant, but it's much less. And we're not going to help the situation by turning to other widely available materials like steel, aluminium, etc. Now then people say, well, we have to use more biomaterials, and I'll come back to that point, but the point here is how much can we produce? And it's been calculated that replacing just 25% of concrete with wood, for example, would require planting new forests 1.5 times the size of India. Now, that would be absolutely great, but even if we could do it tomorrow, this would hardly deliver anything by 2050 because typically trees take about 20, 30, 40 years to grow. And then what's happening here? Yes. Okay, then we have to look at where those materials are going to be consumed. So this is a very interesting graph where we got the data for individual countries and made this plot of GDP per capita, which is like development state, versus cement use per capita. And it's very noticeable that all countries go through this kind of hump in their cement use, and then it comes down again. In fact, if we look back over the past 70 years, the amount of cement we're using in places like Europe has gone down, even though the population's gone up. Now, what's completely changed this global situation has been what happened in China. In China, there was a very concerted development. Something like 800 million people were lifted out of poverty, and that required a lot of cement. But now demand in China is really going down very, very steeply. Bear in mind that consumption in China is still 1,500 kilos per person, compared to about 300 in those countries like Japan, Germany, USA, etc. So we have to think, what's going to happen in the future, and we can take that data. China's a bit of an outlier, but the rest we can take an average, and then we can make a projection for what materials we're going to be using in 2050, and no surprise, this is totally dominated by cement-based materials and steel and a bit of timber. And okay, this is taken from a kind of macroscopic analysis, top-down. If we confront that with a bottom-up approach based on published data for the needed floor area, for urbanization, etc., we get this calculation here. And what's interesting is that they're based on completely different premises, but they're pretty similar. And because we have the data by country, we can see where this demand is going to be. And here you see 75% of the anticipated demand is going to be in regions which now have GDP per capita below the world average. That's to say developing regions. So what can we do about it? And here's the answer to the first question. What we can do about it is a lot. Because we have many, many strategies that can all add together to give very substantial reductions. A fairly small amount from timber substitution. We can do a lot with better design, which most people picked out. We can do an awful lot more by making our concrete more efficiently. We can do a lot by substituting materials in cement with lower carbon materials. And then when we come to steel, we can do a lot by moving away from blast furnaces and switching to electric arc furnaces. And we have this tiny amount from some recycling, but I hope you see that actually circularity doesn't really come in here. Not to say we shouldn't do it, but this is what can happen in the global north, but that's not where the big construction is going to take place. You can only reuse materials if they're already there. And the great thing about this, I didn't highlight it, but in fact here we showed that we can reduce already, by technologies available today, 73% of existing emissions from cement and steel, which is just enormous, and it's pretty close to what the IPC says has to happen, which is between 45 to 85% in these heavy industrial sectors. And what's, to me, the most important message about this is we no longer have to say to developed countries, oh, we have this global warming problem, so you didn't develop, you didn't benefit from that, you've just got to stay in the situation you are because it will lead to more emissions. If we follow business as usual, and all these countries which are on the left-hand side of the hump, they're going to increase their demand for building materials, and in a business as usual scenario, their emissions would go up. But if we implement just three things, better design, calcined clay, and better concrete. And then all these countries, even though their GDP is increasing, they're developing, their emissions from cement-based materials can go down. That's a very important message and a very important thing to focus on. And one of those things that is mentioned here is calcined clay. This is behind the cement we developed at the Laboratory of Cementitious Construction Materials here at EPFL. And this is just the simple substitution of about half the carbon-intensive part, which is the clinker, by a combination of calcined clay and limestone. This has already been implemented in 33 plants worldwide, but the potential is much, much higher. The potential is to reduce emissions by 400 to 800 million tons per year, which, to put that in context, that's 10 to 20 times the emissions of Switzerland. And that's what we should be caring about, because CO2 doesn't know any boundaries, so where we can have most impact, that's the most important place. We then did another study, which was more specific, to look at what savings we could make in an individual building. This is a typical kind of low-rise, multi-family dwelling, very popular all around the world, and many people think is the kind of right level of densification for urban centers. And we calculated this in the way it's done at the minute, business as usual. We tried to implement all the things we already know in terms of eco-concrete. We looked at timber, we looked at bamboo, we looked at stabilized earth. And the CO2 footprint is shown here. Now, what's important here, we go from business as usual to eco-concrete, we can halve emissions just like that by technologies that are already available today. If we think about biosubstitution, well, it's very controversial because there's lots of arguments about what accounting method you should use. I'm not going to go into all the details, but this one on the right here is including the harvest emissions. You have to remember that when you cut down a tree in the forest, about half of it just rots in place, the roots and the branches, and in some countries, forestry practices are even worse, can lead to even higher emissions. But let's not get into that, because the point is we have this emissions we can do now. Cement stabilized blocks, not saving as much CO2 because they contain cement. And people often say, well, we just put a little bit of cement in these earth blocks, but a little bit of cement is quite inefficient. As I said before, the problem is land use, because that's the size of your building, and that's the kind of size of the bamboo plantation you would need to build that house. And that's the size, 1 kilometer of square forest you would need to supply that in timber. So if we've got those forests and we can exploit them sustainably, fine, but you can really quickly make the calculation. If people are living in urban agglomerations, then the land area isn't available. And then we add this all together, the availability and the CO2 reduction potential, and you can see this is the different solutions, evaluated differently, but by far the biggest savings come from implementing eco-concrete, which can be done in 100% of buildings, even tomorrow. And how do we evaluate buildings? Well, there's a poster on this, and my colleague's going to talk a bit more about it later, but we have to have good metrics. So what we're trying to do in the Center for Worldwide Sustainable Construction is bring all these parts of the puzzle together. Because unless we integrate with the materials, with the design, with the metrics to measure anything, then we can't realize these potential gains which are there. So, I hope that was fast enough, but we need to really keep remembering that CO2 is a global issue. It doesn't help to just solve little niche problems in our backyard. Speed and scale is essential. We have most of the solutions, and therefore we should be implementing them and not saying, well, this is not perfect. Let's wait until we have something that's completely carbon neutral. Then we're going to be waiting around while we all fry. Low carbon concrete and design can instantly deliver a lot more than bio solutions. So that's it from me, and I'll hand back to Rue, who will introduce the next speaker.
Thank you so much, Professor Scrivener. And just to remind you, the first question, which was if we fully scaled existing low carbon materials across the different materials, how much embodied carbon can we reduce? It's by greater than 60%. And then the following question was, what will reduce embodied carbon in buildings the most by 2040? And it's design efficiency. So the next speaker, Professor David Ruggiero, will hopefully shine more light on design efficiency with his presentation titled The Structural Diet.
Okay, good afternoon. Thank you, Rue. Thank you for having me here. So yeah, today I'll talk a bit about what we can do on the structural scale to reduce the embodied carbon, specifically of our buildings. And in essence, my argument is going to be that we're overbuilding. We're using more material than we need to, and that we need to find ways to economize and use less material right from the design stage. So you know the statistics already, that the world is growing dramatically and that we need to build more, at least in some parts of the world. And buildings are a huge source of our global emissions, and about 10% of CO2 today comes from embodied carbon due to construction. That's the CO2 associated with the materials themselves. And within this, I would say, it depends by building, but you say on average 60 to 80% of that embodied carbon in a building is due to the structural materials. So the role of structural design is critical if we really want to limit the carbon impact of our construction. We need to limit the amount of structural materials we use. We're talking about the concrete, steel, bricks, timber, and we've already had a good discussion on the different types of structural materials. And so I won't wade into the debate about which material we use. The point is that whatever material we're using, if we use less of it, if we use it more efficiently, then there's going to be a reduction in carbon footprint. I'll pause here for the first little quiz question. Yeah, so, nope, the other one. Okay, so thank you. So in a typical multi-story reinforced concrete building, which elements usually consume the largest volume of concrete? I'll wait 20 seconds or so. Okay, interesting. So started out with floor slabs and then foundations caught up. Well, I would say, based on the data that we have from many structural designs, this is 3 individual data sets from some structural engineering companies. Slabs and floor systems are the lion's share of the embodied carbon. Foundations and walls together also add up quite a bit. Columns are generally not a large share, and transfer structure, and what exactly I mean by that, we'll talk about in a bit, but that can also be significant. But definitely the single largest contributor is floor systems. And there's been, now when we talk about the types of construction that we're seeing, there's been a shift in the last couple of decades, let's say in the types of buildings that structural engineers are being asked to design. We have CAD and BIM and finite element analysis tools that allow us technically to design, let's say, very interesting, irregular, complex structures. And this is being pushed by different architectural trends and sometimes issues of land scarcity in the places that we want to build these buildings, and that's fine. But my point is, these buildings look like they want to fall down. It's because they do, and you have to do a lot of work to keep them from falling down. And if you need to make this stand up, you need to put a lot of concrete and steel into it to counterbalance that. And naturally, this comes at a price. So these kinds of buildings are heavier and more carbon intensive than buildings with a simple structural system. And this is a general trend. If you introduce structural complexity, you increase embodied carbon. A few examples. So cantilevers, very popular architecturally, but very bad for carbon. I've done some other studies where we said that there was a 50% embodied carbon premium for cantilevers. This is results from MIT. This is something similarly. We don't have to look too far to see an example of this. So the new RTS building just outside has these bold second story floating floor, and to make this work, they needed to make these huge steel trusses, not to mention the concrete walls to support the trusses, but the numbers on this, the embodied carbon just from the primary steel framing, so these trusses and the floor beams of that level, not considering the concrete slab, comes out to about 300 kilograms of CO2 per square meter. And that number might not mean too much to you, but for comparison, in a typical commercial steel frame building, the floor framing might be 50 kilograms of CO2 per square meter. So this is 6 times more intensive than a traditional building. If we talk about projecting vertically instead of horizontally, well, then okay, we talk about skyscrapers and pencil towers, and it's been well known since the 1960s that building tall comes at a premium for materials and cost, and therefore also embodied carbon. The taller you go, the more you're fighting against wind, the more material you need to put in. And some of these really tall towers have walls that are up to almost 2 meters thick at the base to withstand the wind forces. And there's also an interesting study that others did about vanity height, the height of spires, and just the fact that you put a spire on the top of your building will increase the embodied carbon of that structure by 10 or 15%. But I want to show something that's maybe more commonplace, more insidious maybe because it's less seen. It's often covered up by the skin of the building, but it's there in the skeleton. So this is what I'm talking about when I say transfer structure. So transfer slab or beam is something that allows a vertical discontinuity. So the force coming from a column above is then shifted to these new support points. And this is done for many reasons. If you have multi-use building, or you have a parking grid, or you have some infrastructure below, sometimes you're forced to do this. And other times, I would say it's less necessary, but just done out of convenience for realigning architectural grids. But it has a big impact. Some of these transfer slabs can be 2 or 3 meters thick. So you think just about the embodied carbon there, and you understand that, as we did in this study here, you could have a 20 to 100% premium, so increase in embodied carbon over the entire structure by introducing these transfer levels. Just for fun, here are some pictures of transfer structures from my hometown of Toronto, and again, this was ubiquitous there. When I worked in practice, we were designing like 3 of these before breakfast, and it's still going on like this. This is a dog's breakfast here, where you have 3 or 4 different transfer levels to make that thing cantilever over the heritage church there. This is a complete realignment of the structural system above that very thick transfer slab. And this one I show often is maybe my favorite example, because if you look at those columns, not a single one lines up from top to bottom. So every slab is a transfer slab. Every slab is 20, 30, 40% thicker than it needs to be. Well, okay. So maybe you see what we were talking about a bit at the beginning. I want to return now to the topic of slabs. As you see, they are quite prominent in our construction, right? You see a lot of material. So now we can put the other quiz question, please. So which of the following measures typically has the greatest influence on slab thickness? So the amount of concrete we need to use in slabs. Okay, that's good enough. I think maybe everybody in the audience here has a little statics background, so you know QL squared over 8. So indeed, the span is the most predominant factor. It's the thing that scales the thickness up most dramatically. I have some similar graphs, but this is one from the literature where we see that a typical residential span of 7 meters or a commercial span of 9, 10, 12 even has a very high embodied carbon per square meter. But if we were able to reduce this to 4 or 5 meters, even 3 is kind of a typical hotel room grid, just to give you an idea. So we would have a dramatic reduction of the embodied carbon coming from our slabs. As I'm talking about span, I can't pass up the opportunity to talk about the building that we're currently sitting in. Maybe some of you were here during its construction. It's really, really impressive, the scale of it seen from the air like this. But it's also a lot of material. The slabs that form these arches are 60 to 80 centimeters thick, and they span, I think, 60 or more meters in the longest one. So that's a good ratio, but the grand span here is purely architectural. It's not like we're building a bridge across a valley or somewhere where we need that span. So you can question, is this choice, is the creation of that space worth it? Would it have served its purpose just as well without all that embodied carbon? But ultimately, okay, we can accept that there's an artistic or cultural value to individual structures, and we want to talk more about the scaling factors of typical structures. So going back to floor slabs in general, we've also done research looking at ways of mitigating deflection of floor slabs, because many slabs are deflection governed. We make them that thick because they would otherwise sag too much. And there are things we can do, talking about construction sequence or materials, or even limestone, calcined clay cement has some nice synergistic properties here because it actually tends to creep less over time, is what we're finding. Or we can question the entire premise that flat slabs are very common in Switzerland and North America. Other parts of the world, not so much. This is one place where we have a divergence between the monetary economy of a system and its embodied carbon, because flat slabs are cheap, they're easy to form, but they have more embodied carbon than a ribbed slab, which is more complex to create. So maybe we can go to even more exotic methods of optimizing our slabs, using Nervi-esque designs. This is what we do with topology optimization in one project. But at some cost as well, because now we understand that a ribbed slab system is deeper, so you use more of your available height for the floor system, and owners tend to like to maximize the number of stories they can fit in their parcel. So I've spoken about the carbon cost of structural irregularity and the importance, in particular, of floor systems. Last thing I'll touch on just briefly is a sort of more systemic factor that leads us to heavier building designs. This is really a simplified reliability basis for how we design structures, and there's always uncertainty in the world, and we can never design something to be 100% safe, so we assign a target reliability, a certain acceptable risk, and that's fine. And this naturally leads us to design with safety factors, and that in and of itself I'm not calling over-design. That's normal. We rely on reliability theory to tell us what the safety factor should be. The problem is this inequality here is an inequality, and the codes just tell us that this is the minimum requirement for safety, but there's no upper limit. So the problem comes when we stack on additional unnecessary factors of safety. And in practice, we don't usually design every element right to its limit with the code safety factors for a lot of reasons, which I won't go into in detail, but we tend to be more cautious, and it looks from this data like a lot of engineers kind of have a hard wall at 85% utilization. They won't really like to go up into the 90s, but we should. That's already calibrated into our safety factors in the code. Another study I don't reference here is that it tells us that just by grouping similar elements, like similar columns together, well, they're not all going to be equally utilized, and you waste about 15% of the potential of the material by doing that. And this also happens at the material scale. This is a complicated graph, but basically this is data from one construction site where the engineer designed it with 35 megapascal concrete, the blue line, but the on-site actual rendered material is almost 60 megapascal strength. And the engineer never takes advantage of this additional strength that they could, and we've shown that you can also reduce the thickness of the slabs by 10% if you account for this. It's just hard to know in advance because the concrete providers are a bit risk averse themselves and they will always shoot high. Okay, so I've said a lot of things that we shouldn't do, or really I've outlined the design decisions that can allow the structural engineer to have an impact on the embodied carbon. I think if we want to slim down our buildings, we should definitely negotiate shorter spans and more regular structural systems. And to do this, we need buy-in from the entire design team and owners to think about embodied carbon early on at the concept design phase when you really have the ability to make big changes. And individual engineers should also be aware of systemic over-conservatism and own their technical analysis and expertise to really improve their accuracy and thereby reduce their extra factors of safety. So this is part of the puzzle, but I think if we make improvements at the material and structural and urban scale, then I think we stand a chance to meet these decarbonization goals in the construction sector. Thank you very much.
Thank you so much, Prof. Ruggiero. And our next speakers are from Holcim's Department of Circular Economy, and it's François, Girod, and Hermant. So if you can come up. I think we have Slido questions for them as well, to just set the scene.
Hello, everyone. Here are the questions. Hold on a second here. How much of the construction concrete is recycled in Switzerland? Suspense. Do we recycle concrete?
Is it possible?
Is it possible? Oh, wow. Excellent.
Very interesting.
It seems not possible, I guess.
Okay, we have something to develop, huh? Yeah. Good, let's do the second question.
Normal building, not the one we saw before in Toronto. Wow. The one you made in the morning, before lunch.
All right.
Okay.
François, you're responsible to remember the answers.
Hold on a second, this 25%, okay. Mm-hmm.
And the audience is responsible to spot the answers in our presentation.
Exactly. And then we will cross-check at the end.
Okay, let's get going.
So I'm glad to have Clemens, my colleague from Zurich. He's a SD person in charge of sustainable development, and I'm in charge of circular economy, and we work together as a big team. So I will go and challenge this boy who's making the strategy. So Clemens, what are the challenges in the cement and concrete production?
All right, I guess there is hardly anything to add after all these presentations we have already seen. So challenge climate change, decarbonization of the construction industry, of course a big topic as well for us as a company, and resource scarcity. The only thing that is for me quite interesting, everybody really talks about climate change, and most of the people know as well about the size of the challenge. And hardly anyone really talks about the resources scarcity topic and the real circular economy in construction industry. And I'm not sure whether you are aware of the mountains that the construction industry is moving every year in Switzerland. So we are like using 70 million tons of construction materials every year, and a bit more of that volume, so 70 to 75 million tons of construction and demolition waste. So, and this basically means if you open up your eyes and on the streets you watch the trucks, you will realize most of the trucks are actually transporting construction materials. And then if you combine that with that as a society in Switzerland, we have a very low recycling ratio, although we believe that we are actually quite good if we think about PET recycling, but PET is 70,000 tons a year. So it's actually quite sobering that we as a developed society are not any further than that. So,
yeah, looking at these figures, it seems it's quite depressing, huh? Like Professor Beyer said at the beginning also, we have a big challenge, but she said that with a big smile, and you seem to be concerned, huh?
Yeah, well, I mean, it's not all bleak. There's actually a silver lining on the horizon. So if you look at the construction material value chain of concrete and cement, it's actually like a match made in heaven for circular economy. And here you see figures from Holcim, but I'm sure that is quite similar with any kind of construction material player. We are the biggest supplier of construction materials in Switzerland. We sell about 9 million tons every year of cement, concrete, aggregates, things like this. But on the other side, we almost recycle 5 million tons of materials from the waste market. And this is the amount that is increasing, not the construction materials. So a few years back, we were at 4 million tons. Now we are almost at 5 million tons. So this is really a sign that this value chain is quite apt for closing resources cycles. And if you look at all these levels, we use all these levels in different ways. And in the past, we thought our big issue is actually the level of clinker production, because that's where the CO2 emissions are coming from. That's where we actually reproduce our CO2 footprint. But there is as well an advantage. We have a high temperature process there. There we can basically destroy harmful substances. And recycling is only good recycling if you can exclude, destroy, or at least immobilize harmful substances. That's one of the major points for us. I will now go to one of the points in the question before, how many tons or what's the percentage of recycled concrete. So I go to the concrete level, and you will be surprised. So more than 80%, okay, with all these figures, it's pretty difficult actually to measure the amount of materials going where. But more than 80% of concrete is already reused. Deconstruction concrete is reused in Switzerland. Figures from the industry go above 85%. This is at the order of magnitude from like PET recycling, plastic recycling, etc. So we are actually quite far there. Here you see two pictures. On the left side, you see natural aggregates, and on the right side, you see recycling aggregates from deconstruction concrete. You see it's very clean. You don't have any contaminants like plastic, steel, cardboard, etc. So that is very high level, good quality material.
No, Clemens,
you have a concern?
Come on, you say bullshit. Look at these things. Do you think this is high quality? It looks really scary, you know. It's nothing to do with a nice natural stone. Look, don't tell me you can make concrete of quality with that. Sorry.
I mean, we need critical people.
I don't believe you.
We need critical people like François. They keep us on our toes. Of course, François, you're right. This does not look like really natural aggregates. And what you see there, these gray phases, this is actually cement stone. So that's what happens when you harden cement with water. What is the quality of that material? It's porous. It takes then, if you produce new concrete, it takes water. And it takes more water than natural aggregates. You need more cement. You need super plasticizers. So in the end, you add cost, you add CO2 footprint, and you actually have less performance at the end of the concrete. But there is a solution. So this is the challenge that we took. We wanted to basically separate these two materials, the aggregates from the cement stone, and this is possible. Maybe one comment, of course, this is now for developed markets like in Switzerland. So in sub-Sahara countries, this would not be of any value, this technology. But here in Switzerland, as we have quite high levels of concrete recycling, this can add value. So we actually invested in a technology which is called smart crushing. This uses the differences between stone and cement stone. Cement stone is quite brittle. And this crusher introduces only the amount of energy necessary to break the cement stone, but not the natural aggregates. And the result of this is that we can separate in aggregates stones that are almost as natural aggregates. So water demand goes down by 80%, no performance loss, no additional water necessary, no additional cement necessary. And at the end, we can as well separate a high concentration cement paste. This is what you see to the left. So we can ensure cement to cement, concrete to concrete recycling. And if we do this cement to cement recycling, we can save in Switzerland up to 400,000 tons of CO2. So we produce out of this, once again, clinker phases. We produce something that can harden at the end. And this is substantial. In Switzerland.
Clemens.
Wait, give me
it has been shown by Professor Scrivener that a circular economy will not solve the issue. It was, if I remember correctly, the last efficient measure. Of course, we are a mature country, we're not in a developing country, so there's a built environment available, but we cannot also destroy all the buildings in order to feed the need of concrete production.
Okay,
it's a bit greenwashing. Come on.
Thank you. You realized I'm very fascinated about this technology, and you keep me grounded. Thank you very much. Nevertheless, this is 20% of the emissions of cement in Switzerland that could be saved, but you are right, it does not solve the issue. And here we come once again to what are the big figures in our industry. We use every year 40 million tons of concrete in Switzerland. Of course, that goes with economy, etc. And if you compare this now to the 6 million tons of deconstruction concrete, you can use 1,000 smart crushers to treat the 6 million tons of deconstruction concrete. You will never make from 6 million tons, 40 million tons concrete. So, François, you challenge me all the time, so what's the solution to that? What is your suggestion, what to do?
But there's no Slido here. Maybe we should either destroy more buildings, that's really sustainable maybe, or what else, build less, stop to construct. I know some architects also from the EPFL, they say I don't want to build anything, it's not sustainable. Is this the solution? I don't know.
Okay, good. I mean, your first solution is not a very good sustainability strategy to produce more waste, but I see the mathematical logic. With your second point, in a society that is still as well growing, with aging infrastructure, we still need to build, we need to satisfy the need. But we heard as well some answers before from the previous speakers. So we actually had a look how efficiently our product is used in the final structure. And this was first not motivated by sustainability. This was motivated by, we know if we want to reduce our CO2 footprint by 30% till 2030, we have to invest like 300 million Swiss francs here in Switzerland. So we said, well, are there any more pockets to actually achieve something similar? And when we saw how our materials are used in floor slabs that we just discussed before, we found that in some constructions, up to 75% of the concrete used in the floor slabs are structurally not necessary. This is not what we heard before, because before we talked about structurally necessarily additional concrete. But even if you build the normal way, if you do not have all these cantilevers, etc., our floor systems use very inefficiently concrete. And that's why we focused on some new startup ideas. Here you see two examples. vaulted flooring systems, like in Ripman floor systems, where basically through geometry you want to solve how the pressure is actually distributed. With this, you can remove like 70 to 75% of the material used in a structure, in a floor system. And the other topic is carbon pre-stressed concrete, a startup that we bought a year ago. With this, you actually produce the concrete not with reinforcement steel, but with reinforcement carbon fibers. They cannot corrode. And by this, you can reduce the amount of material you use.
Clemens,
well.
We have 1 minute left.
1 minute left.
So do we really have something on the ground, or is that just a concept from a funny startup?
For both. So the topic of Ripman floor system, this year the first commercial building will be built in Zug. And for CPC, CPC is actually the material of choice for balconies, bridges, etc. And last year we built a showcase for a flooring system. You see that here. And this flooring system we are commercializing now. And as I said before, material reduction about 80%. You have as well a very big impact on reduction of CO2 footprint. That's something that we will push into the market over the next years.
Does it solve the CO2 issue?
In
2 words, because
maybe.
There's no more time.
In 2 words, yeah. Let's jump to the end.
Yes.
So does it solve the CO2 issue? No, we need to actually combine everything you saw, everything you heard as well in the beginning, you know, using LC3 cements, using smart crushing, using these new ways to build and the new materials. If you combine it all together, we get a very big step ahead. And my dream is that the next project that we want to push is a big deconstruction project where we actually treat the deconstruction concrete with the smart crusher, use the materials to build carbon pre-stressed concrete plates, and by this build out of one old building 2 to 3 new buildings. And I guess with this we are then one major step ahead to a decarbonized circular economy in the construction industry.
Thank you so much for a very entertaining and engaging way to talk about the circularity. Next up, we have a presentation from Professor Gabriele Manoli from the Lab of Urban and Environmental Systems. And we have 2 Slido questions as well, so take your phones out again.
Thank you very much. All right, hello everyone. So let's take a look at the questions, first of all. So, sorry? No? There should be a picture, no, somewhere? Okay. Well, so imagine big buildings with trees on top, okay? So, and then the question is like the vertical forest in Milan, for example, okay? The question is, this forest building of 36 floors with 80 trees and other plants on it, does this building look sustainable? Just imagine it for today. Yes, no? Let's see. Okay. So mostly no. Okay, yeah, I think we can move to the next one, right? So I think most of the, yeah, so there is a clear 74% for no. Good. Is there another question next? Yeah. Okay, and then how many years and how many trees would we need to absorb CO2 for the building to break even in CO2 emissions compared with an equivalent building without trees? So then 5,000 trees, 60 years, 80 trees, 3 years, 80 trees, 3 years, or 100 trees, 5 years. I'll show you a picture of the building later in the talk, no worries. So you all right. Good. Thank you very much. So I hope you will find the answer soon in the presentation. Okay, so hello everyone. So I'm Gabriele Manoli. Thanks again. It's really a pleasure to be here today. And now I want to slightly change the focus and let's say zoom out a little bit from concrete and buildings and look more at the challenge of urban sustainability, let's say in general. And indeed, when I discussed with Frederick and Dimitris, this event, they mentioned this idea of design or lean design inspired from manufacturing and engineering as a way to how shall we design the future cities, right? In order to make them more sustainable, more efficient, greener, healthier, and so on and so forth. So let me focus for a second, right, on this idea and the concept of design itself, right? So traditionally in engineering and planning, what do we do? So we start from, let's say, we have a complex system, we have a problem, which again is typically complex, right? So we start thinking about possible solutions, and you see at the beginning the conceptual part is messy, but then you have an idea to solve the problem, and you start iterating on this initial idea or prototype, and that's where the design process starts, right? So you iterate, you test, you validate, until ideally you converge to the optimal or ideal solution that should create some value, but also minimize the cost, and ideally have no or little impact on the environment. But what I want to do today is basically to challenge a little bit this idea in the context of cities and urban planning and urban evolution. Because what I want to argue is that unfortunately, urban planning and many issues related to our cities are not so easy to solve because there is not a single or well-identified solution to a problem. And I want to do it by focusing basically on two pillars, let's say, of the ongoing debate on urban sustainability, which is urban greening on one hand, as you imagine from the questions, and this idea of urban digital twins. But let's start from the greening part, okay? So I think you're all familiar. This is, again, an example of green building, right, that you imagined a few minutes ago. So a building like this, for sure, it provides a lot of benefits and ecosystem services. So, trees can remove CO2 from the atmosphere, they can increase cooling during hot weather, but they also reduce air pollution, risk of flooding, and then you also have benefits in terms of biodiversity, and also mental and physical health for the residents. So in this sense, specifically to cooling, we did some work a few years ago, and for example, we showed that urban trees can reduce local temperatures during the summer, so when you have heat problems. They can reduce temperature by up to 6 degrees, as shown on this side here for the city of Phoenix. However, this cooling effect of trees depends on many factors, including where you are geographically and what's the background climate. And for example, in a place like Zurich, the actual cooling benefit is more likely in the order of 1-2 degrees. So first question is this cooling effect really enough? Especially during like a heat wave, right? Or in the context of future global warming. But then we should also remember that the cooling benefits of vegetation are possible only if there is available water. So trees need water to transpire and to be also efficient in cooling. And this is a clear, so you clearly see this. So this is London in 2022 during a heat wave. So basically it was an exceptionally high temperature. So basically when cooling by vegetation was most needed. And yet, because it was hot, but also dry, also plants were stressed, especially grasses and short vegetation. So the cooling effect of vegetation was definitely reduced compared to what you would have wanted or originally planned. And so, if you want to provide cooling through vegetation in cities during hot weather, you need water and you need irrigation. But this can create conflicts with other water uses. And for example, this is significantly a problem if you're in an arid region, arid climate, and that's an image of Los Angeles. And basically there, every summer, they put severe restrictions on the use of the use of water for non-essential purposes, such as greening urban vegetation. But then, we have potential benefit, the cooling, but we need water with potential problems in certain places. But we also need to target the most vulnerable population if we want to really provide benefit and reduce the risks. And here comes another problem, right? Because vulnerability and risk depends on many factors. First of all, it depends on the age and gender of people, if you have any pre-existing conditions. So it really depends on the demography and characteristics of the population. But the real exposure of people also depends on where you are, what you do, so what's your behavior and your mobility patterns during typical days. And for example, there's just an example, right, of the mobility flow, so the population movement within and between Lausanne and Geneva, which is like a study that we have just done in our group. And another problem is that greening provides cooling outdoor, right? But people, like we do spend most of our time indoor. And that's then another issue, because indoor conditions can be, so indoor temperatures, especially during a heat wave, can be much higher than the outdoor ones. And that's clearly illustrated by that time series from Canada, actually, where you see that there was this heat wave period, and the indoor temperatures without AC is the red line, and it's much higher compared to the black one, which is outdoor conditions, and the indoor condition with AC, which is the blue one. And the problem there is basically, you can have prolonged hot conditions, but also you basically do not have the cooling at night, which is beneficial for health, and if you don't have it, it's really problematic, and indeed in that case there were several temperature-related mortality, so related death. So this basically brings another challenge right into the picture, because we need outdoor cooling, we need also indoor cooling, but if we cool indoor with AC, then we are basically increasing energy consumption and carbon emissions into the atmosphere. But luckily, vegetation can also be helpful in this case, because we did the study, for example, here you see images for simulation for different cities, and basically trees, so street trees, by shading buildings, can reduce the energy consumption for air conditioning indoor. And here you see basically that different cities for different levels of tree canopy cover on the x-axis, you reduce the energy consumption for AC by 10–20%, depending on where you are and depending on the characteristics of the urban morphology. So, but as we have briefly seen before, actually this is the building you should have seen before. So, so there are indirect benefits of vegetation, but there are also direct ones in the sense that, as mentioned, trees can uptake carbon directly from the atmosphere. But we also have to be careful in this case, right? So first of all, we need to remember that vegetation is a carbon source, so sink, but can also be a carbon source. And for example, here this is a recent study made by colleagues at EMPA, where they quantified the CO2 fluxes in Zurich. And you see on top that anthropogenic activities are clearly the major source of carbon emissions. And below, you see the carbon uptake by vegetation, illustrated by the green arrow, which is negative. But you immediately see that the problem that the sink is typically occurring in this case during summer, but for most of the year, the carbon sink by vegetation is either very small or can even become positive, meaning that vegetation is not a sink anymore, but it's actually a source of carbon into the atmosphere. And then, to connect to the question you've seen before, we should remember that, even if we achieve carbon neutrality, ideally locally, this doesn't mean that there are no, all the embodied carbon emissions that we've seen and have been discussed before. So, for example, all the trees on a building like this, it would take around or more than 50 years just to offset the carbon emissions needed to construct the balconies, only the balconies. So just to put numbers in context. And again, this is just an example of a study on the topic. And of course, this was mentioned already, but I think it's important to stress, right, that we can try to achieve carbon neutrality locally, and vegetation can help in this sense, but we should not forget that all the activities, infrastructure and so on that, we construct and we build today and we use today, also, even all the technology that we use, rely on carbon emissions that are emitted somewhere else. So we are just externalizing basically the cost of our lifestyles somewhere else on Earth. And this is well, depicted by this map of the carbon flows embodied in the international trade. So, so we have seen that anyway, there are pros and cons in vegetation, but still I'm not saying that we should not promote and use vegetation in cities, because again, they do, and vegetation do provide a lot of benefit locally, from cooling, carbon removal, but there is also significant evidence now that access and exposure to vegetation have positive effect on the physical and mental health of residents. And for example, again, this is another study that we did with colleagues in Singapore. We basically studied the tree, so the residential tree canopy across Switzerland, and we compared it with the Swiss national cohort, so mortality data from the Swiss national cohort, and indeed, consistent with actually the literature on the topic for other places, we found a clear association between exposure to green spaces and reduced all-cause mortality. So this is basically shown on that image over there, where you see the hazard ratio is basically the mortality risk. It decreases with the tree canopy, so the amount of trees you see and you are exposed to, but also with the level of aggregation, as shown on the bottom there. So in short, the more vegetation, the more trees, and the more aggregated they are, the lower the mortality risk for the population is, and the better, let's say, the health outcomes locally again. But here comes, another question then arises. So who is really taking advantage and benefiting from this, all this positive effect of vegetation? And this is actually an important question to ask, because evidence shows that the poorest and the most vulnerable population typically are excluded from the benefit, the local benefit of vegetation or greening interventions. And this is, I think, well depicted by this image here, where you basically see Los Angeles again. On the right, you have the income, different neighborhoods, and you clearly see the low-income neighborhoods, so the one with the light green color, are the one exposed to higher temperatures, so darker red on the left. Meaning that, the poorest and the most vulnerable are the most exposed to climate hazard and risk. And this observation is basically linked to a phenomenon which is called green or climate gentrification. And a typical textbook example of that is the High Line in New York City. So what happened there is basically the city invested in green infrastructure, in a large-scale green infrastructure project to improve the life of local residents. But what happened is basically after constructing this, the price of land, so the housing prices and the value of properties skyrocketed, so it increased significantly. And the local population, basically, which was low to middle income, was displaced at the advantage of real estate investors and wealthy population groups. So all these examples, I think I gave you, many informations, ideas, and topics, but it was really meant to show you that cities, right, and urban problems are more than the sum of their parts. So whenever you introduce an intervention, you might have cascading or non-expected consequences somewhere else in the system. So just to recap, right? So we can introduce greening in order to improve microclimate and with the expectation of providing health benefit or reducing climate risks. But this really depends also on the exposure and emissions, which depend also on the mobility, transport sectors, and the energy sector, and so on and so forth. And all of this is locally, actually. And also mobility and greening, modify and affect accessibility, which have then effect on house pricing and so on and so forth. So all of this has then cascading impact on construction processes, but also demographic changes, segregation, inequality, and so on and so forth. So the idea now and the hope is that with the AI, digital twins model, right, we can try to solve many of these problems. But the problem is that existing tools basically are not able and are not up to the task yet, because they cannot capture this systemic complexity of urban systems that goes beyond single sector, but really an interconnection of social, physical, ecological, and economic dimensions. And also, we can aim for more data, better models, better AI tools, but we should not forget that the processing power and the memory required by all these algorithms grows exponentially as we increase the number of variables and interactions. And this is clearly shown by this study here. So the problem is that basically we're trying to solve a problem with the same thinking that created it in the first place. Because all this computation contributes to carbon emissions in the end. So I think I convinced you, I hope by now, that urban planning, unfortunately, is a wicked problem. What does it mean? Well, it means that you have stakeholders which have conflicting goals. So now you have residents who want affordability and developers who may just want profit. And you have the fact that every interaction on the system changes the system itself. So, you green with a specific objective, but then you reshape the market, you change the migration and demographic patterns, and so on and so forth. And this happens because you have many interconnected subcomponents, right? So you have housing, transportation, demography, environment, and they are all interconnected with complex and nonlinear feedbacks. And all of this happens on long time horizons where you have a lot of uncertainty, right? So demographic changes, technological shift are difficult to predict. So at the end of the day, there is not a definitive solution because the system, right, is the dynamics of the system are basically evolutionary in nature in the sense that cities are continuously evolving and adapting and self-regulating in response to internal but also external forcings. So just to quickly, conclude, basically at the Laboratory of Urban and Environmental Systems, we are trying to untangle these complex interactions that occur in cities, and we are developing models which are multi-sector, multi-scales, in order to really understand and explain the interaction between, behavior, but also mobility, transport, energy, and so on and so forth, in order to inform planning. And just to give you a quick overview, for example, we study how cities evolve in over long time scales in time and space. This is London, the evolution of London over 200 years, and you see how population and transport networks co-evolve together. But we need to study also how people move, what they do, where they do it, and again, this is the people entering and exiting the London Tube during different times of the day, and if you notice, these dynamics actually resemble the heartbeat of an organism. And finally, of course, we want to understand how all of this is connected to local climate in terms of feedbacks and interaction. And again, this is another animation, always for London, of the urbanite islands, so how temperature is modified locally and by the regional circulation. So to conclude, my message today is that basically driving sustainable urban transitions requires a systemic approach, as was also mentioned at the beginning. So we really need interdisciplinary method across the ecological, social, and economic dimension of cities, and also a multi-scale approach that considers both local but also global problems, and from seconds, right, to decades or even longer time scales. We need also an evolutionary perspective to the problem because we need to focus on interaction and feedback loops and points of leverage rather than strict optimization or selective services and operations. And we, at the end of the day, we also need some shared values and bottom-up initiatives because we really need to rethink, let's say, our long-standing separation, right, from the biosphere if we want to drive positive change for the future. Thank you very much. That's it, and I'll be more than happy to discuss with all of you soon.
Thank you so much to our presenters. We're going to take a brief shift at the moment to some short pitches and from startups and organizations that are working to decarbonize construction in some shape or form. And then afterwards, we'll then jump right into the panel. So if you have questions for the speakers, just jot them down or commit them to memory, and then we can ask a bit. First up, we have Medusoil, represented by Nicolas Hermant.
So, hi everyone, I'm Nicolas Hermant from the company Medusoil, and I'm very happy to be here today to present to you how to go from the lab to the field with an innovative and sustainable solution that is designed for today, but also for tomorrow's world, which means obviously with more and more nature hazards and stronger environmental regulations. So I won't spend much time to detail the situation of our planet. I think we all know it if we are here today. We also know that the construction industry has a major impact on our planet and on the CO2 emissions. But that said, we all know, and it has been said many times today, that cement and concrete are essential. They are necessary products. And the point is definitely not to replace them, but more to improve them, to use them at the right place, and to develop some alternatives. because complementary approach exists, and I'd like to present you the one of Medusoil, which is based on the nature, because by Medusoil we use biocementation. Okay, biocementation uses microorganisms that are able to precipitate calcite crystals, and these crystals will grow in the mineral matrix, binding the particles together and bringing cohesion and reinforcing the soil, improving the geotechnical parameters. So for instance, if I take some sand, thin sand, non-cohesive, when I use biocementation binder, at the end I've got something cohesive and strong. Okay, this is not very new. Anyone can do it with cement or lime. So then the question is, why to use such binder? Actually, today we are at the Sustainability Collider. So let's talk about sustainability. This sample that I showed you has been produced using a very low quantity of binder, and at the end a very low carbon footprint. And we are very proud of that. This is a major figure, and we are happy to be part of the climate protection. But sustainability is not only about CO2 reduction. With our binder, we do not impact the groundwater. Why? Because we have a pH neutral solution, so there is no alkalinization. With our binder, we also don't impact the biodiversity. We have certified our products as non-ecotoxic according to the HP14 Eurofins protocol. And those points are very important because, for instance, it allows us to use our binders in type S water protection zones in Switzerland or in Natura 2000 sites. So this makes a difference. With our binder, we do not impact the resources. We protect them because actually our microorganisms, we grow them internally in our bioreactors. So we don't have any impact on the resources. And our solution is fully circular. We have zero waste from production to execution. Actually, our only byproduct is now valorized as a fertilizer homologated by the Federal Office of Agriculture. And last point, we developed a product nitrogen-free, which is quite important now since nitrogen is more and more regulated across Europe. So as you see here, it's not only about CO2, it's also about the global impact on sustainability. So if I step back to the title, how to go from lab to field, of course you have to implement the right formulation of your product so that it's easy to use, it can be injected, mixed with soil, even sprayed, and then it's just a question of scale up, and that we did with our company. We have now our own factory and a mobile plant that is producing big quantities, helping to serve projects across Switzerland, Europe, but also worldwide. So at the end, your question might be where to use these binders. Actually, in many use cases, it can go from protection of rivers to swelling clays remediation, pit soil improvement, and we are more and more involved in projects to improve some new materials by substituting part of the traditional binders for a binder which brings a better environmental impact on the final product. So it's not anymore proof of concept. We are really in the real world with this solution and in applied engineering. So yeah, I hope it was interesting, and feel free to reach out if you have any question. Thank you.
Thank you so much. Next up, we have GBDI with the Zuhaib, Batra.
Can we have the presentation, please? Hello, everyone. I am from EPFL, of course, working under the leadership of Professor Katrin Scrivener for the Global Building Data Initiative. As we know, we have seen so many numbers in the presentation in the beginning before, This is the way we can improve the design. This is the way we can improve our efficiency in construction. And there can be several ways in which we can do things. I'm here to talk about the big elephant in the room. And that elephant is, we all have been that elephant actually in our lives, and that's about data. So the initiative that we are working on is filling the gaps with data. And in GBDI, we are focusing on some of the biggest problems that have long lingered in the building and construction sector, and we are trying to fulfill those ambitions by efforts on developing solutions that help us refine the data that is available in the building sector. So we understand that building sector has main 4 key phases where construction is happening. We see it's in the beginning phase when the material construction is produced. We know that there is a lot of manufacturing happening. We know there is construction phase. There's so much information available on that as well. There is a phase in which the construction is finished and then it's operation of buildings for 50 to 100 years. Similarly, it's the demolition phase that follows that. But in all these phases, one key gap that is missing is the documentation of data. How much emissions are happening in operational and embodied side, and how can we really understand that? That gap is very huge. We know there is a lot of information about materials. There's a lot of information about how we transport things, how we assemble them, how we demolish them. But this is hardly documented in an efficient way. And it's not only a gap that we know is in the global north, but it exists across global south. That is what Global Building Data Initiative does. We are working on consolidating this data through this initiative and looking into the life cycle assessment process to help make better decisions about the design of our buildings. Better data means better building and a better planet. We are helping with this initiative to take better decisions, having data-driven insights through the work that we do. We are helping businesses to inform their data, how they can improve it, and also construct that gap and make things easier for different stakeholders who are in the industry, and making better design decisions. We have mainly 3 work streams in GBDI, and the first one is working on a harmonized open data building format. And this format is basically going to help different industry stakeholders to exchange data with each other without barriers and understand it very easily. The second thing is the open source data platform, and this platform is definitely available now and online, and we are using this as a means for people to share the data and exchange data in Global Building Data Initiative. The final one is about collaborative effort. So we are working not only in Europe, we are working beyond boundaries of Europe, whether it's in India, whether it's China or Brazil. So we are expanding our network to make these work streams work together. Our data platform looks something like this. We have a lot of functionalities that allow people and user or even anyone from the stakeholder industry to actually get in there and join this platform, access it, understand it, and actually exploit it for making decisions and choices that have been very hard in the past. So we have a small version of Open Data Protocol already, which is under revision, and it will be further updated for the use of different stakeholders. It's simple, it's scalable, and it's open access. This is what we are working on. We know global floor area is going to double by 2060, and this is a very huge problem. That is why in Global Building Data Initiative, we have a very wide network of stakeholders whom we are working with. As you can see, we are expanding the geographies of what we are working on, and EPFL is one of the lead partners taking this initiative beyond the boundaries that we are working in. So I look forward to talking further with you on this initiative and understanding your data needs. Thank you.
Thank you so much. Our next presenter is Coopérative Origo. Thank you.
Good afternoon, everyone. We are the construction cooperative, Origo, and we bring together architect, craftsman, and engineer. Under horizontal governance, we design and we build, and we share a deep conviction the construction sector can be decarbonized. So at Origo, we do something very unusual. We bring together those who calculate, those who draw, and those who build, not just in the same project, but in the same cooperative. It's because for us, sustainability is not just about material. It's about relationships, it's about trust, and it's about know-how we built along the way. So together, united skills, we shape a construction sector that is truly made to last.
So, just really fast, we don't have much time, it's true. But the Coopérative Origo started really as an idea of answering to an offer that is a demand, which is really going up in the region of the Suisse romande. And we realized there was no hardly a way to answer to this demand, which is constructing with the bio-geo-sourced materials. We realized we needed to change certain things, to pass from a model where there are little and small enterprise of craftsmen that now cannot answer to big project, to something more federation of it. So we created Origo. It's shaped along 4 poles, that's how we call them. So we have projects, so it's really the idea of projecting and building with these materials, which we talk about bio-geo-sourced materials, come from French bio-geo-sourcé. I guess this will be the translation. But of course, geo-sourced, many of our materials used in construction are geo-sourced. But when we talk about geo-sourced, we mean things which are local and almost zero emission in their construction, production at least. So of course, natural stone construction, but especially earth construction. So every concrete which is clay based in its binding. And bio-sourcé, everything it's fibers, which also contain CO2 embedded, which we can store also in the building. Wood construction is, of course, bio-sourced. We also work with remploi, reuse of materials. We do project, we construct, we do consulting, but we build, we do conception and building, from conception to the building itself, because we have also craftsmen, engineers, and technicians in the cooperative. We do research. We research old and new ways of using old materials. We do also what we call a certification for these materials. We do formation événement, which is the training. We train professionals. We realize that many architects start to design with these materials, but not many people then can build with it. So to train professionals is really important. And then we have the Entraide, which is an association of mutual aid and humanitarian activity and exchange internationally. We exchange knowledge on this kind of constructions. And I would like to say many things, but I think I have to pass. Maybe we just tell you a little examples of our research materials.
So imagine a plant that spreads like wildfire, that reaches 3 meters in a season, and that it's almost impossible to eradicate. That plant is so invasive that the canton of Vaud mandates its destruction. And every year, 100 tons of this plant is incinerated in French-speaking Switzerland. That plant is Japanese knotweed, and here's the paradox. We burn a plant that captures CO2, and we insulate our building with imported fuel fossil. So we talk a lot about circular economy, but we burn valuable plant fibers because simply we don't know what to do with that. And so at Origo, we do. We are developing Renouer Renouveau, the first bio-based insulation material made from local knotweed. Turning an ecological disaster into a climate opportunity.
Of course, the first material built with this kind of plant, because nobody wants to use this kind of plants. You need almost a permit from the Confederation to be able to use the knotweed at the moment. But we show them by drying it up and binding it with clay, for example, instead of lime, which we do with hempcrete, for example. We can use a material that has the same property of hempcrete with lime, with all the benefit of earth construction, which is the regulation of humidity, air. There are many, many other good things, but not too much time to explain. But what is really important in this specific project is that we use the knotweed. The normally at the moment has to be incinerated because we cannot use it in the compost because it grows everywhere. So we save the CO2 from this incineration. We save the CO2 which is captured by the plant anyway by storing in the building. The CO2 of all the materials, petrol-based or cement-based, which we don't use, and the end of cycle of this kind of material, which are clay, binding with clay, is that you can reuse it completely, 100% forever, without needing even the question of recycling. There is no energy in recycling for this kind of elements. And I find a pity that in all analyses we have seen before, there was always, the only earth construction I've seen was always with concrete stabilization, which we don't need necessarily. Up to 4 stories we can build with earth construction without stabilization, but I didn't see it before appearing. Yeah.
So we will close here. You can come and visit us in our space in Geneva, the Origo. This is a participatory construction site built by the member of the cooperative, and it's almost done only with reused material. Yeah.
So yes, this is the project. Yeah, it's finished. Everything is really nice, calm, and voilà. Merci.
Thank you so much. You can also talk to them after the session. Next up, we have SEPAR.
Check, check. Yes. And this one also works. Perfect. So, hello everyone. My name is Artem. I am the founder of the startup SEPAR, where we explore how to work with the demolition sector. So at first I would like to think about the idea of sustainability itself, and if you would go to a dictionary as I did and check what is that, you will see that it's basically the ability to maintain a certain value over a long period of time. It's better to, okay. So it could be different. It could be economy, it could be environment, it could be social value, but at the same time, the core principle is something that could be held and survive over a long time of period. But at the same time, if we look at cities, we see another dynamic. And about 100 years ago, sociologist Maurice Halfbachs, he studied how cities changed over time, and his main idea and his main focus was a collective memory. And he observed that every time a new wave appears in a society, the old values, they change. So it could be new generation, it could be new political priorities, it could be new economy situation. And new values, they replace old memories and old values, and the city changes, and he called this process expropriation. And we started to track this process at SEPAR. The first project we did was a demolition map platform, because the outcome of each expropriation is basically the building that was demolished to be replaced with a new one. And we built this platform to track and to show how many buildings are demolished every day, and what are the volumes of materials that could came from this process. What we see is that it's quite a constant process, and with this technology we also consult large-scale portfolio holders. For instance, there you see a project for Canton Vaud, where we consulted them on urban mining strategies. We made an analysis of a building stock of 250,000 buildings, went through demolition waste reports, and built a simple prediction model for the future demolitions. One clear thing that came after this analysis is that land is usually more valuable than buildings and materials, and buildings are often demolished much even before when the true end of life of these materials happened. So the only truly stable thing is land. And for us that means that sustainability tends to a certain resistance, but in the opposite there is always this process of expropriation. So something loses its value and needs to be replaced. So it's a nature of dynamics, and otherwise it's stagnation. So if we look on a building level, there are some sustainable strategies that are aligned with this, so to say, opposition, and building loses its value and became elements. Next elements became waste, waste turned into aggregate, and aggregate loses information and became something that could be used as a generic material that can be used in any possible scenario. So the system is very adaptable, but it also loses information, which is kind of value in this paradigm of expropriation. But at the same time, there are some historical examples where the information is preserved. So for instance, the famous one is Japanese temple that is rebuilt every 20 years. And the builder participated in this building for 3 times. So he started as a student, next he acted as a master, and finally he finalized as a teacher. So when structure is dismantled, it's reused in new construction. And the important thing that I like about this example is that this element contains knowledge about how to build again. So the geometry itself contains information about assembly. So this idea is quite important for us and for the project. Do you have an idea how to click on this button on the bottom? It shall be 12. The previous one? Yes. And if you click on the button, is it clickable or? It's basically the digital version of this slide, but if it we won't be able to launch it, it's okay to go with the next one. And if you click on, okay. No, I think it's fine. I mean, all these images was with a bit of movement, but if we want to be able to do it, it's also fine to show it like that. So the target of us is to create a scalable system where structural components can be integrated in new buildings without any compromises in safety. So we focus on concrete structures to preserve their structural information when buildings are dismantled. So for this we develop and work on the industrial scale quality assessment of concrete structures, as well as the connection interface to make it assemblable with the other construction materials. In this way, we can build a building that can last not for 40 years, but for ages. And with this type of approach, once we think of materials as something universal and that could long for a long time of period, we came to a more sustainable way of building. That's the vision of SEPAR. Thank you.
So hello everyone, I'm very happy to be here, thank you. So I'm Thibault Demoulin from Oxara. Oxara has been founded in 2019 as a spin-off of ETH Zurich. And now we are a team of 14 persons who are all committed to provide to the construction industry binders that are sustainable, affordable and circular. So these are the three criteria on which we base all our technical development and all our business decisions as well. Let me just go through what that means for us. So circularity is the basis on which we make the binder, because not only it helps to preserve resources, but it also provides a material which is usually cheap, because we can see it as a cost negative. The cost of landfilling is saved, and we can have a cheaper component of the binder like that. It also supports affordability, and if these materials, which are waste, are not over-processed, they are also sustainable. Based on that, we have two different lines of products. One which is based on excavation waste, which is basically soil and clays, and one which is based on demolition waste. When processed and mixed together with appropriate activators or admixtures, we can have a binder that can be used for different purposes. So if we use excavation waste admixtures, we can make a material which is poured earth, which is similar to concrete in its workability, but based on clays, or compressed earth blocks. If we use demolition waste with a proper activator, we can make a cement-free concrete. Here are some applications that we have now. So compressed earth blocks together with the company TerraBlock. Clay-based floor with or without terrazzo finish, like here with a key bag and repoxite. You see the implementation, and you see the final picture of the floor. We can also make clay-based exterior wall, like here in Vendôme with the company Marty. Also hybrid elements, such as this timber earth slab, which is of particular interest since slabs are usually heavily carbonated as a building element. And here the wood and the clay together compensate disadvantage of each other, right? We can also do lean concrete, which is for us a very good opportunity to enter a market because it has, well, little requirements, no certification, so we can have a cement-free concrete in these applications, and we can have volume that leads to lower prices afterwards. So wool-less floors, so demolition waste-based floors, or prefabricated elements such as terrazzo tiles with Elfer, or dry cast pavers with the company Créabeton. So, well, if you want to know more afterwards, I'm very happy to discuss further. Thank you.
Thank you so much to all our startups and organizations. And if I could just invite the presenters from earlier to the stage for the panel. François and Clement, who is going to represent? Thank you so much, and thank you everyone for your patience. If you've got questions, there is a mic here and there, so when you have a question, you can just walk up to the mic. But just to get us started with the conversation, I just wanted to ask all panelists, we've clearly said there's ways that we can decarbonize construction and make it better, but what do you think is typically missing from the conversation of sustainable construction or sustainable development in general that leads people to the conclusion that there's not much to be done? We need one big solution one silver bullet that's going to fix it all for us that hasn't been discovered yet.
I'm not sure if I can give a very insightful answer, but I think it's a good question because people tend to fixate on silver bullets and try to find something that is magical and hopefully doesn't require much effort on our part, so we can keep on living our lives the way we do and just apply this new solution. But I think the reality is more nuanced, that we have to make compromises in certain areas and apply the known methods, things that are proven and work and can scale in many different, let's say, many different levels of scale, from the materials to the structures, to the urban scale as well.
Yeah, I've thought many times about this question, and I don't really know the answer, but I think it's partly because we've lived through a time where we have seen such remarkable changes. If I just think about how we've gone from telephones we had when I was a child to these mobile phones we all carry around with us, how our lives have just completely changed in terms of air travel, things like that. I think we've kind of got used to thinking there can be near miraculous things that occur, and that leads us to forgetting that when it comes to something that's heavily resource-based, we can't change the composition of the Earth. We can't, because the composition of the Earth is to do with the composition of the universe. So, I mean, it's a bigger problem than that. And I think, that's the problem. We've seen so much change. We really think miracles are possible.
Yeah, for me, I mean, there is definitely no silver bullet, but if we look at everything what we have seen today, and if we combine all that, we will get a very long way. And only if I look at my little speech, the elements that I showed there, I mean, this was the results of the last 5 years of work to put basically together what are the levers that we can use. And we actually found the most important thing is collaboration along the whole value chain, look at all the levers and bring all ideas together.
So from my side, well, I do agree. So in a sense, I think that there is simply no silver bullet. And maybe a mistake that we make the risk of doing is that we believe that technology can be the only solution, but indeed all these problems are also social and cultural, right? So sometimes behavioral changes can, have similar or better impact, and the problem is that then, it's really a global problem, and we see that, then you have all the complexity of the social, political situations that don't help. So, I mean, unfortunately, I think it's much more than technological issue, and that's where, I see the problems and the promises and problems.
And you actually brought up, Clement, you actually brought up a very important point about bringing all the stakeholders to the table to kind of get to resolve this issue. But then how can we get all these stakeholders to actually agree on something? Because realistically, if we're speaking, I think the problem with a lot of construction begins at the brief stage, not even at the design efficiency, because the structural engineer is going to receive an architectural drawing or design or brief that already has been determined, and you just have to do the structural mapping for that. So how realistically can we change this mindset for a very client or developer designed industry?
I mean, for us as a material producer, it means to get out of our comfort zone. In the past, it seemed a bit like we produce our construction materials for the truck that is picking up the construction material. And so we need to try to understand what are the real problems on the construction side, what is happening there. And we need to talk to investors. We need to talk to who and understand how their business is actually driven. And what I find, you need to understand where the benefit lie for the individuals. And if you identify the benefits, you can make a value chain that works for everybody. But there, I guess, we have some gaps, because sometimes for investors, there are little to no benefits to be sustainable. And there we need to do some proper thinking.
David, do you have anything you'd like to add?
Yeah, I mean, in my time in industry, I was on some good design teams and some bad design teams where it was possible for the structural engineer to have a real say in the early stages of the project. So it's definitely possible for good collaboration to happen. But maybe even, yeah, it needs to go a level higher, that, you know, the owners and planners and policymakers don't really understand the issues that we're dealing with on a technical level, and we need to be better at communicating these relatively simple ideas to the higher levels.
I'd like to take a question from the floor, if anyone has any questions. I think the mic is right behind you.
Hello, thank you so much for the panel. So I just want to jump on one comment that you made, and it was regarding getting all of the stakeholders right around the table. And also with the team of Girod, I'm sorry, the other pair, yes, the member of the pair. Yeah, you mentioned, I think it's really essential, but there is one thing that was not mentioned is at the two ends. One is the, of education, and I can only speak from the North American model and African models that I know, because I just arrived here 2 months ago. And it's really in the field of architecture, sorry, I'm an architect and civil engineer. What we lost in the educational field is this sense of ethics that we need to pass on to our students. And David, in your example in Toronto, which is an extreme case, students that are actually encouraged to do this crazy design with no carbon footprint analysis whatsoever, and that leads to those crazy towers and condos that we see everywhere in Toronto, unfortunately, in Vancouver. So I think this is one important component. I think the education and the designers of the future and engineers, this needs to be part of the curriculum, maybe as part of the grading system. And then finally, the other end of the spectrum is the policy. So to be able to have incentives for the investors that maybe have no incentives today to be sustainable. But I think our leaders have a responsibility also to set up certain standards. Thank you very much.
Thank you so much, Aziza. Anyone else from the floor? Yes, please. If you could introduce yourself and tell us where you're coming from.
David Senoizan from HESSO Val-de-Valis. I was surprised not to hear anything mentioned about residential floor space per capita. Yeah, I'm not an expert on construction sector at all, but the few papers I've read, they mentioned that the technological solutions and improvements alone won't be able to solve the problem, and that reduction of floor space per capita was a really important solution. So perhaps my question goes more to the first and the last speaker. Professor Manoli, you mentioned behavioral changes. What do you think is the room for reduction of floor space per capita in residential buildings?
Yeah. Thank you very much for the question. Yeah, that's exactly the type of behavioral change that I mean, right? So, for example, I think there are actually people in the audience working on this, simply increasing, keeping the same volume, but having more people. And actually that's what happens in big cities. Like if you look at the floor per capita in Japan compared to here, I mean, it's much smaller at the amount of space that have, for example, for bedrooms, right? So that's the type of small behavioral, but again, it requires really cultural shift that are not that easy to and you need education, right? You need not just technology, you need like a whole set of educational and social and probably political, contribution. So no, fully agree with that, but maybe there are other comments on this.
Yeah, I just wanted to add, it's a question of what can get you most progress fastest. And, when we see that 75% of future demand is in countries with below average GDP, then we realize these are countries where the floor space per person is very, very small, and the normal aspirations of these people is not to be living, in China we've seen the floor space per person go in the past few decades from about 3 square meters per person to about 10. 10 square meters per person is still a very small square area, but when you multiply it by 1 billion people, it's a lot of extra building. So, of course we need to change our behaviors, but we're often coming at this from our very rich, very well-off perspective, which clearly we need a lot of changes in, but we also need to be realistic about this huge pent-up demand, which we're not going to change fast. Whereas, we had frequent demonstrations, the amount of extra material we're putting in buildings is easily 50%, if not 75%. You may need a bit more challenging to. So that's again, of a factor of 2 we can do now with implementation without telling people, well, you've only got 3 square meters, you've got to stay with 3 square meters, which is not an easy message that's going to go down very well.
Thank you very much. Yes. Oh.
Yeah, thank you very much. So my name is Tal Harris. I'm with a climate think tank called Future Cleantech Architects. I wanted just to ask, out of curiosity, how much conversation like this do you have with counterparts in China, in Sub-Saharan Africa, in Asia, where in general where construction is really booming? How much openness, curiosity there is for this?
Well, we do spend a lot of our time there. Rue's joined us specifically to help our dialogue with places like Africa. We spend a lot of time with China. I mean, the GBDI program that Zuhaib presented, one of the main things they're acting on now is to, let's talk to the Chinese, because it's all about simple metrics. We have these very complicated life cycle analysis, which people use for iconic buildings, but we need simple analysis people can use for everyday buildings. So yeah, I would say, for me, 90% of our time is spent in these places, talking to these people, looking at international venues like, COP, things like that. That's where the future is.
And if I could just add a little point in there, I think it's really important that we do have these dialogues, especially in those areas, because what we run the risk of having is these conversations, which are typically held either in the global north or somewhere like by the EU or by the UN, where there's no representation from people from sub-Saharan Africa, where they make decisions which are slightly dangerous, like dictating what kind of materials will be needed in those areas without understanding the local context. So I think it is quite important to make sure the conversation of sustainable construction is perceived as a very localized conversation, even though the goals are for a global solution.
So maybe the perspective from a global construction material producer, yes, I was representing the situation of Switzerland, but what we do, we work as a network. So what we develop here, what we do here, we look whether we can apply this as well in all other countries where we are present. And this is actually the idea that one country learns from the other. So this is for the group, this is daily life. So we might be here in Switzerland, but it's relevant what we do here for all other countries.
Any question from the floor? Yeah.
So hi again. One question maybe regarding the cement. We talk a lot about CCUS. We didn't talk about that today. What do you think about it? Is it really like the solution, or could it slow down in a way or improvement of the recipes of the cement? Because we say, okay, we take the CO2 out, so fine, no need to improve more. What about the CCUS? What do you think about it?
Everybody looks at me. I try to dodge the bullet. No, CCUS is the last step, definitely. I mean, what we have seen today, there is a lot we can do with known levers, and I'm strongly advocating that we have to basically pull out all the plugs to use everything we know, and then what remains we need to actually tackle with carbon capture and storage. And then we can get into a debate, should we already start now, at least to capture parts of it? Maybe to learn how to really do it, to get basically the logistics correct, because there's a whole new value chain as well involved. I mean, if you discuss that out of a Swiss perspective, we do not have the pipelines. We do not have the logistic hubs. We do not have the storage places yet saved. So there is a bit of thinking, maybe we can do showcases to learn how to set that up for the end game. But you know, at the end, it's a question of society that costs a lot of energy. And I guess we should save as much CO2 before we go to CCUS, because then the question is, do we use the electricity to capture the CO2 from our kilns or to drive around with our Teslas? So.
And I think that's an extremely important point, because we know carbon capture and storage is going to be expensive, but it's also this energy consumption. You know, we're trying to invest in renewable energies, but we're barely catching up with the increased energy demand we have, even without these very intensive processes like carbon capture and storage. I mean, the remarkable figures for China, China now has more installed renewable capacity than the whole of India's energy consumption. And yet, still in China, they're still building coal-fired power stations because they can't keep up with the increasing energy demand, you know? And you see so many papers publishing this, you know, idealistic zero-carbon solution, and then you see it's based on a premise that we have this unlimited renewable energy in the future. We're never going to be there. So we absolutely have to do everything possible. And that's when I mean that we have to stop the perfect being the enemy of the good. We have to do what we can do now, and we can do fast, and we can do relatively cheaply. I'm not saying we stop working on carbon capture and storage. Obviously, we're going to need that to some extent. But we shouldn't just be sitting around saying, oh, we're going to have carbon capture and storage in the future, so let's stop doing the things we can do now. tends to be the complacency we have. It's like, you know, wanting a silver bullet solution to come from the sky, because we've been so used to these technological miracles that we've been inundated with for decades now.
Maybe one additional comment. I mean, it's actually in full swing. I mean, I talked out of the Swiss perspective, but if you look at all over Europe, till 2030, we will have captured like 5 million tons of CO2, which makes then like 8 million tons of cement completely carbon neutral. So this is in full swing. So that's huge investments, huge projects going on. But if you look at the projects, they have all critical advantages over Switzerland. They are mostly very close to coastal lines and to potential storage sites.
Thank you so much. Demetrius, if you can.
Yeah, just a question from an outsider. I realize that we have the technology, what you'll be saying is we have the technology to do it, to reduce the carbon footprint of construction, and by design, by materials, whatever. I was just asking, we haven't talked yet about regulations. Is regulations a factor that you could imagine entering into this, so you only do buildings that have a certain CO2 footprint? I'm not aware of anything, but please.
No, regulations are moving. They are moving. I'm not saying they're moving fast. They could always move faster. I mean, we now have, I think it's 5 countries in Europe which are demanding that people do carbon accounting. Of course, again, you know, that's good, but we need to have more simple measures of accounting that are more quickly adopted. We have got movements in standards. We need to move further. I think it all goes together. We've got to move on all these fronts, and we've got to get the people connected. But sometimes people use slowness of changing standards, again, as an excuse for not doing anything. It's like, oh, well, we have this very miracle solution, but the standards people won't let us have it in standards. And, you know, what we forget in buildings, we forget that these incredible buildings like David showed, you know, these ones that look like they're falling over, this is based on more than 50 years of structural study. And if you then come with a material that doesn't behave like a conventional concrete or conventional steel or conventional something else, you'd basically have to redo those 50 years of research. So it wouldn't ever, you know, so this is my kind of argument against these like niche solutions. Don't really go anywhere, because it's normal you can't change regulations that fast. You have to ensure safety and everything like that.
In the meantime, can I say something to regulation? I mean, once again, Swiss perspective. I guess in Switzerland we have a lot of additional work to actually explore the limits of our current regulations. I guess this is the first job that we need to do before we complain about regulations.
Maybe if you can just quickly jump in, and maybe a question for you also, because where the regulation should be set, right? Because again, we saw that the problem is global in scale, right? And most of the issues, so we can set new regulations in Switzerland, but the impact is probably not going to be seen, right? Because you need regulations in, you know, Asia, Africa, and so on. So that's where I don't have an answer, right? But you know, you definitely need regulations, but where and at which scale is? You disagree? Okay.
I don't know if we go to an argument, but we have regulations for things like that pollute. You take your car, you have emissions, and there are regulations for the emissions, right? I would imagine that we have regulations for buildings, that we don't overcome a certain level of CO2 footprint. Again, I'm not in this business, but I just think, is it something that could be done, or is something that is done already?
Yeah, it's very much something that could be done. As I say, already these regulations are in place in 5 countries in Europe, and then it needs to go further. So very much it can be done, and you know, that's also the point for making these tools easier for people to use. So exactly, it should move, but it shouldn't be an excuse for not doing other things. Yeah.
Thank you for your presentations earlier this session, and they've been very insightful. We see that you all have really different strengths in the work that you do. My questions come down to basically understanding that it's so far now established most of the construction is going to happen in low and middle income countries over the next 50 years or more. We see that a major share of construction sectors are informal in those countries, and it's a very big challenge. What would be that one direction that you see this informal construction sector handling in order to really achieve the decarbonization that we talk about across the world?
Rue, you can answer that question.
Me? No, that's a tough question.
I mean, I would also want to hear what Gabriele will have to say, because I think that does impact the growing urban space. But I think that is a very complicated question, which has been passed to me. But it is true that the majority of the construction will be informal, but that doesn't mean it's inaccessible. And I think the bigger thing now is having a clear understanding of what we mean by informal, and this isn't talking about slums or anything like that. It's very much the idea that the urban development in a lot of these countries far precedes how the infrastructure development happens. So you'll see people will start building, and then the provision for services and water and roads and all of that will follow 5-10 years later. And you can't really stop that design. It's just going to keep happening. So the idea now should be, how can you intervene to ensure that people are building better now? And the idea would be to not tell them what material they should use, but to make sure what materials they have access to are better materials to use. And then maybe empowering them with tools and enough education and understanding to use less of that material, because at the end of the day, the things that dictate how people are building is affordability and the accessibility of that material. If you tell them, now you have to go find a specific material that takes weeks, months to find, and it costs triple, they're not going to buy it. So it really is that definition of sustainability, which has to include affordability. I think one of the presenters had a little beautiful triangle that had those three on it, and I think that's a very important factor of it. Anyone else want to?
Oh, no, maybe just reminding me something that a professor told me when I was at school, and that basically you think about environmental issues only when you have 3 meals a day, right? So I think at the end of the day, if we don't reconsider, right, the role of the developed and rich, in the global context, I mean, it's difficult to really, address this type of problem. So it's a higher level question of the distribution of wealth and so on and so forth, which I guess, it's complicated and it's challenging.
But I think, what we do see is that there are ways of improving quality, improving affordability, and lowering CO2. That is important. There is a space in that triangle.
Thank you. That's
Aziza, do you have a comment?
I just wanted to say that this is one of the key questions that my lab is going to be, investigating in the next few years. Is how do you make specific material? One of the investigations with, LC3 available and actually cheaper than the regular cinder blocks. This is the material, availability, as it compares, kind of to the competition. So working with the industry, but I would say also the architecture and the layout. You can have a great material, but it's there to build a box without, any windows, and that the roofing material is terrible. You're not, achieving your goal nor the thermal comfort.
Thank you so much. And just a final question for our panel. When you leave now, what would you say is the one thing as your priority to ensure that sustainable construction happens, or decarbonization construction happens? What's your number one priority?
I think number one priority is to get people to understand what can go at speed and scale, and stop investing a lot in these kind of micro niche ideas.
Agreed.
I mean, my #1 priority, first of all, is get our decarbonization roadmap steaming ahead. But what I really am in for is I want to do showcases that show the people what you can do with what we know today. And I said it before, what I'm working on now is I want to do a deconstruction where I build at least two buildings out of one old building with the new technologies we have at hand now and combine everything we know so that we have lowest CO2 emissions. This is really my dream.
Yeah, from my side, I work tangentially on construction, but maybe building on what has just been said, my #1 priority is to provide quantification in terms of, okay, what is the expected benefit or cost? Right? To really give numbers just to focus on what can work and put aside what is not working or not providing the expected outcomes.
David, I will come back to you with one final question. What would you tell a structural engineer now to help them be better or feel better about the sustainability of construction?
Yeah, sure. I think structural engineers have a very can-do attitude, or all engineers do. We try to solve problems. So when somebody comes to you with a never before done architectural scheme, you just want to make it work, and okay, you take some pride in it as well. But maybe there's a place for that, but there's also a place for pushing back a bit and having some discussion and going back to a tradition which predates this age of computers, where the structural engineer and architect were more we're often the same person, or we're more in tune in making structures that follow the load path.
Thank you so much. And I'd like to thank our panelists for a very insightful afternoon, and thank you all for attending. And if I could just synthesize the afternoon for us, I would say what we've learned is that there's a lot of complementarity across the value chain, and it's absolutely necessary that we come together as all stakeholders, architects, engineers, developers, when you become a real estate developer, and kind of view this as not a competition between materials, but rather how can we use each material efficiently and correctly in the right scenarios. And I think maybe this will help everyone understand that it's not always about not building anymore, but maybe figuring ways to build better with what we have, and building efficiently or rebuilding efficiently, and using our assets that we have in a much more productive way. So just thank you for being panelists, and thank you for listening. I'll pass over to Fred once again.
Thank you, Rue. Thank you, everybody. So I will close shortly, because I don't want to reinvent the wheel on what you said, and I don't have also silver bullets about the sustainable construction. But the key point is that we saw that there is multiple levers, and we need to push them from the sustainable design, from the low carbon materials. It's important to bring the value chain around the table, as you said, from the public policy, from the regulators, from also the corporates, academics bringing also many solutions, startups also as the solution providers, and we needn't also to forget all the citizens, because we are also the end users. So it's also our behavior will have an impact also on all the ecosystem on the value chain. In any case, when we are talking about value chain, we can talk about collective intelligence, and it will be the next step for you, means the apéro. And if you can put the last slide, what you will see, we have a bunch of different stakeholders, solution providers, startups, but not only, also initiatives as Tech for Regen, and also you will see the Smart Living Lab in Freiburg with multiple also stakeholders from the academic sectors working together to have an impact. So I will invite you to join the apéro and to meet them. And the last but not the least, I want to say a big thank to the committee of the organization. And there you can raise your hand from also the Sustainable Worldwide Construction Centers, Rue for sure, and a special thanks also to Dimitris Noukakis there, because it's a special day also for him, because it's his last event at EPFL as an organizer. Since you are not so old, I will say, but you will retire soon, no? Well done. Good job. So many thanks to all of you. And now please go to the apéro. Thanks.